The banana begins its journey in a place of warmth and gentle rains. In tropical regions where the air hangs heavy with moisture and the sun moves slowly across wide skies, the banana plant stands quietly in prepared soil. This plant is not a tree, though many think of it that way. It is an herb, a giant herb that grows from underground structures buried beneath the surface where human eyes cannot easily see. Deep in the earth, a corm rests in darkness. This corm is a rounded structure, firm and pale, holding within itself the beginnings of what will become. The soil around it is dark and rich, filled with nutrients that have accumulated over time. The earth is loose enough to allow roots to spread, dense enough to hold moisture between the particles that make up its structure. Water moves slowly through this soil, finding its way downward, touching the surface of the corm, encouraging something to begin. From the corm, small roots emerge. They push outward in all directions, moving through the tiny spaces between soil particles, growing longer each day in their patient search for water and dissolved minerals. These roots are thin and delicate at first, exploring the underground world with slow determination. They branch and divide, creating networks that spread wider and wider, establishing the foundation for everything that will come later. Above the surface, a shoot appears. It pushes up through the darkness of the soil, moving toward the light that filters down from above. This shoot is tightly wrapped, rolled upon itself, protected as it makes its journey upward. The soil particles shift and move aside as the shoot continues its patient climb. When it finally emerges into the air and light, it begins to unfurl very slowly, revealing the beginning of what will become a broad green leaf. The first leaf opens to the world with calm deliberation. Its surface is smooth and green, designed to capture the sunlight that falls upon it throughout the day. The leaf spreads wider and wider, becoming a broad blade that can gather light and transform it into energy through processes invisible to watching eyes. More leaves follow, each one emerging from the center of the growing plant, each one unfurling in its own time, adding to the collection of green surfaces that reach upward and outward. Around this growing plant, other banana plants stand in organized rows. They have been placed at specific distances from one another, with space enough for each plant to develop without crowding its neighbors. The rows stretch across the plantation in long lines that follow the contours of the land. Between the rows, the soil is kept clear and manageable, allowing workers to move through when needed, allowing air to circulate among the growing plants. The banana plantation exists in a place where rain falls with regularity. Clouds gather and release their moisture, and the drops fall softly or heavily depending on the nature of the storm. This water is essential, arriving from the sky to replenish what the soil holds, to replace what the plants draw up through their roots. In places where rain does not fall often enough, water must be brought to the plants through other means, through systems of pipes and channels that deliver moisture where it is needed most. The sun rises each morning over the plantation, bringing light and warmth. The temperature climbs slowly as the day progresses, creating the warmth that banana plants require to grow and develop properly. The air is humid, holding moisture that can be felt but not always seen. This combination of warmth and humidity creates the perfect environment, the exact conditions that allow banana plants to thrive and produce the fruit that will eventually make its way across great distances. As the weeks pass, the plant continues to grow taller. What appears to be a trunk rises from the ground, growing thicker and stronger as it reaches upward. This trunk is not made of wood. It is composed of tightly wrapped leaf bases, layer upon layer of leaf material wrapped around itself to create a sturdy column. The outer layers are firm and green, protecting the softer tissues inside. New leaves continue to emerge from the center at the top, pushing upward and then unfurling to join the canopy of broad green blades that arch gracefully outward from the central column. The plantation is quiet except for natural sound. Birds move through the air above the plants, sometimes landing on the broad leaves to rest or to search for insects. The wind moves through the rows of banana plants, causing the large leaves to sway gently, creating soft rustling sounds that blend with the other sounds of the tropical environment. Everything happens slowly here, with a rhythm that matches the patient growth of the plants themselves. Workers move through the plantation at intervals, walking along the rows, observing the plants with experienced eyes. They look for signs of health or distress, checking to ensure that each plant is developing as it should. They examine the leaves for any discoloration or damage. They observe the overall structure of each plant. They make note of which plants are approaching the time when they will flower and eventually fruit. This observation is gentle and routine, a regular part of maintaining the plantation and ensuring that the plants have what they need. The soil continues its quiet work beneath the surface. The roots spread further, growing deeper and wider, establishing an extensive network that can draw water and nutrients from a large volume of earth. The soil contains nitrogen and potassium and phosphorus, elements that the plant requires in order to build its tissues and carry out the processes of growth and development. These elements dissolve in the water that moves through the soil, and the roots absorb them, drawing them upward into the plant where they will be used. Time moves forward in the gentle rhythm of days turning into weeks. The banana plant continues its patient growth, adding more leaves to its crown, expanding the surface area available for capturing sunlight. Each leaf follows the same pattern as it develops. It emerges tightly rolled from the center of the plant, then slowly unfurls over the course of days, spreading wider until it reaches its full size. The mature leaves are large, sometimes as long as a person is tall, creating an impressive canopy of green that can be seen across the plantation. The structure of each leaf is simple and elegant. A central vein runs down the middle, with smaller veins branching off to either side in parallel lines. These veins carry water and nutrients throughout the leaf tissue, distributing what the plant needs to every part of the blade. The leaf surface is waxy, helping to reduce water loss during the warmest parts of the day. When rain falls, the water beads up on this waxy surface and rolls off, preventing the leaves from becoming waterlogged. Inside the leaf tissue, invisible processes occur constantly. The green color comes from chlorophyll, a substance that captures light energy from the sun. This captured energy is used to combine water and carbon dioxide into sugars, which the plant can then use for growth and development. Oxygen is released as a byproduct of this process, drifting up into the air above the plantation. This transformation happens silently and continuously whenever light is available, contributing to the slow accumulation of energy that the plant needs to eventually produce its fruit. The plant grows taller with steady persistence. The wrapped leaf bases that form the pseudostem continue to expand, creating a structure that can support the weight of the developing plant and eventually the heavy cluster of fruit that will form. The older outer layers of the pseudostem become dry and papery as they are replaced by newer growth from within. Sometimes these outer layers split or peel away, revealing the fresher layers underneath. This is part of the natural process, a quiet shedding that makes room for continued expansion. Below the ground, the corm continues to grow larger as well. It stores energy in the form of starches, accumulating reserves that the plant can draw upon when needed. From the corm, new shoots may begin to develop, forming what will eventually become new plants. These shoots, called suckers, emerge near the base of the main plant. They start small but will grow over time, creating the next generation that will continue producing fruit after the main plant has completed its cycle. This natural multiplication ensures that the plantation can continue producing year after year. The plantation workers understand the timing of these cycles. They know from experience when each plant was established, when it will likely be ready to produce fruit, and when the suckers should be managed to ensure continued production. Some suckers are allowed to remain and develop, while others are carefully removed to prevent overcrowding and to direct the plant's energy appropriately. This management is done with care and knowledge, with an understanding of how banana plants grow and what they need to produce the best fruit. Months pass in this slow progression. The plant that began as a small shoot has now grown into an impressive structure, standing tall with many broad leaves creating a green crown at its top. The pseudostem is thick and sturdy, capable of supporting significant weight. Inside the center of the plant, deep within the wrapped layers of the pseudostem, something new is beginning to develop. The plant is preparing to flower, which will mark the beginning of the fruiting process. The flower bud forms in darkness, hidden within the protective layers of the plant. It develops slowly, growing larger over time, pushing upward through the center of the pseudostem. This bud contains all the structures needed for reproduction, carefully arranged and protected as they develop. The plant directs energy and resources toward this developing bud, supporting its growth with the sugars and nutrients that have been accumulated through months of photosynthesis and root absorption. Eventually, the flower bud emerges from the top of the plant. It appears at the center of the crown of leaves, a large purple or dark red structure that hangs downward from a thick stem. This stem, called the peduncle, is strong and flexible, able to support the weight of the developing bud as it continues to grow. The bud is covered with overlapping bracts, thick modified leaves that protect the flowers within. These bracts are waxy and smooth, often with a purple or maroon color that distinguishes them from the green leaves surrounding them. The flower bud continues to elongate as it emerges more fully from the plant. It hangs downward under its own weight, a characteristic position that will remain throughout the flowering and fruiting process. The tip of the bud points toward the ground, while the base where it connects to the peduncle remains at the top. This inverted orientation is important for what will happen next. As the flower bud continues to develop, the bracts begin to lift slowly, one at a time, starting from the base of the bud near where it connects to the peduncle. When a bract lifts, it reveals a cluster of flowers underneath, arranged in a neat row. These flowers are small and delicate, with pale petals and visible reproductive structures. In banana plants grown for commercial fruit production, these flowers are primarily female or sterile, arranged in a specific pattern that will determine how the fruit develops. The flowers revealed beneath each bract are organized into what are called hands. Each hand consists of multiple flowers arranged side by side in a single row. The flowers within a hand all face the same direction, pointing outward from the central stem of the flower bud. When the bract lifts to expose a hand of flowers, these flowers are ready to begin their transformation into fruit. The process is gradual and quiet, requiring no dramatic events, only time and the proper conditions. The female flowers, which are located near the base of the flower bud closest to where it emerges from the plant, are the ones that will develop into the bananas people eventually eat. These flowers have small ovaries that will swell and enlarge to become the fruit. In most commercial banana varieties, this development happens without the need for pollination. The fruit develops through a process called parthenocarpy, where the ovaries grow and mature without fertilization. This is why commercial bananas have no seeds, or only tiny remnants of what would have been seeds if pollination had occurred. After a hand of female flowers is exposed, those flowers begin their transformation. The small ovaries at the base of each flower start to grow, slowly at first, then more noticeably as days pass. The flowers themselves fade and dry up, no longer needed once the fruit development has begun. What remains are the developing fruits, small green structures that point upward from the downward hanging stem. This upward curve is characteristic of banana development and gives the fruit its familiar curved shape. Meanwhile, the bracts continue to lift in sequence, moving down the length of the flower bud, exposing hand after hand of flowers. This happens over a period of days or weeks, with each bract lifting when the time is right, revealing the next cluster of flowers in the sequence. The process has its own rhythm, unhurried and methodical, following the internal timing of the plant itself. Further down the flower bud, toward the hanging tip, the flowers are different. These are male flowers and they serve a different purpose. In wild banana species, these male flowers would produce pollen for reproduction. In commercial plantations, they typically do not contribute to fruit development. These male flowers remain enclosed in bracts that may or may not open, depending on the variety. The structure that holds these male flowers, often called the banana heart or bell, continues to hang at the end of the developing fruit cluster. As the young fruits continue to grow, they remain arranged in their hands, with each hand containing multiple individual fruits. The hands are distributed along the central stem in a spiral pattern, creating what will become a bunch of bananas. A single bunch may contain several hands, sometimes many hands depending on the variety and growing conditions. Each hand maintains its identity as a distinct cluster, separated from the hands above and below by small spaces along the stem. The young bananas grow steadily, their green skin developing and stretching as the fruit inside expands. The growth happens through cell division and cell expansion, processes that occur throughout the fruit tissue. Water is absorbed from the plant and contributes to the increasing size of each banana. Starches accumulate inside the fruit, stored as reserves that will later be converted to sugars during the ripening process. For now, the fruit remains green and firm, containing high levels of starch and low levels of sugar. The growing bunch becomes heavier as the fruits increase in size. The peduncle that supports the bunch must be strong enough to hold this increasing weight without breaking. The plant continues to supply the bunch with water and nutrients, drawing these resources up through the roots and pseudostem, delivering them to the developing fruit. This flow of resources is continuous and essential, supporting the fruit as it progresses toward maturity. Weeks pass while the bananas grow. The plantation workers monitor the developing bunches, observing their progress and estimating when they will be ready for harvest. They look at the size of the fruits, the fullness of the hands, and other indicators that tell them about the maturity of the bunch. Different markets and different uses require bananas at different stages of development, so the timing of harvest is carefully considered based on where the fruit will be sent and how long it will take to get there. The skin of each banana remains green throughout the growth period. This green color comes from chlorophyll in the skin tissue, the same pigment that makes the leaves green. The skin is smooth and firm, providing protection for the developing fruit inside. As the banana grows, the skin grows with it, stretching to accommodate the expanding fruit. The characteristic ridges along the sides of each banana become more pronounced as the fruit fills out. Inside each banana, the flesh is firm and dense, packed with starch granules. The texture is nothing like the soft, sweet banana that people eat. At this stage, the fruit is full of starch and has very little sweetness. The transformation from starch to sugar will come later, during the ripening process that occurs after harvest. For now, the banana's role is simply to grow, to reach the size and maturity that indicates it is ready to be picked. The bunch continues to hang downward from the plant, with the individual bananas pointing upward in their characteristic curve. The weight of the bunch pulls on the peduncle, and the plant must maintain its structural integrity to support this load. The pseudostem remains firm and strong. The roots continue to anchor the plant in the soil, and everything works together to hold the developing fruit safely until it reaches the proper stage for harvest. Around the plantation, other banana plants are at different stages of development. Some are still young, with just a few leaves and no sign yet of a flower bud. Others have recently flowered and their bunches are just beginning to form. Still others have bunches that are nearly ready for harvest, their fruits plump and full. This staggered development is intentional, planned so that the plantation can produce fruit continuously rather than all at once. Workers move among the rows, attending to plants at different stages, ensuring that each one receives the care it needs at the right time. The climate continues to provide what the plants need. Warm temperatures persist day after day, creating the heat that banana plants require. Rain falls periodically, soaking into the soil and replenishing the moisture that the plants draw up through their roots. During dry periods, irrigation systems may be activated, delivering water through pipes and sprinklers or drip lines that distribute moisture evenly across the plantation. The goal is to maintain consistent conditions that allow the plants to grow and produce fruit without stress. The passage of time is marked not by calendars but by the visible changes in the plants. A bunch that was just beginning to form weeks ago is now fully developed, with plump green bananas filling out each hand. The workers who monitor the plantation notice these changes and make decisions about when each bunch should be harvested. They consider the intended destination of the fruit, the time it will take to transport the bananas to market, and the stage of maturity that will be best for that particular journey. When a bunch is deemed ready for harvest, the process begins with careful preparation. Workers approach the plant with tools and equipment designed for this purpose. The harvest must be done carefully to avoid damaging the fruit, as bruised or damaged bananas will not travel well and may spoil before reaching consumers. The workers have experience with this task, having performed it many times, and they move with practiced efficiency while maintaining the gentle handling that the fruit requires. A worker positions a padded support beneath the bunch, ready to catch it when it is cut. Another worker uses a long knife or machete to cut through the peduncle that connects the bunch to the plant. The cut is made cleanly with a single smooth motion, and the bunch is lowered carefully onto the padded support. The weight of the bunch is significant, often requiring careful handling to prevent dropping or damaging the fruit. Once the bunch is secured, it is carefully carried or transported to a processing area nearby. The banana plant that has just given its fruit has completed its main purpose. The pseudostem will not produce another bunch of fruit. However, the plant is not finished contributing to the plantation. The suckers that have been growing at the base of the plant will continue to develop, eventually becoming the next generation of fruit-producing plants. The old pseudostem will gradually die back, but before it does, it will continue to support the developing suckers by sharing resources through the connected underground corm system. In the processing area near the field, the harvested bunches are handled with continued care. Workers inspect each bunch and begin the process of breaking it down into smaller units. The bunch is laid on a padded surface and individual hands are cut away from the central stem. Each hand is separated carefully, using knives to cut through the stem material that connects them. This work is done by hand, with workers making quick, precise cuts that separate the hands while avoiding damage to the fruit. The separated hands are placed into tanks or basins filled with water. This water serves multiple purposes. It helps to remove the latex sap that oozes from the cut stems, which can otherwise stain the fruit. It also begins the process of cleaning the bananas, washing away any dirt or debris that may have accumulated during growth and harvest. The hands float in the water while workers gently agitate them to encourage the removal of unwanted material. After washing, the hands are removed from the water and placed on tables for further processing. Workers examine each hand and each individual banana, looking for fruit that meets quality standards. They check the size, the shape, and the condition of the skin. Bananas that show damage, irregular growth, or other defects are set aside. The remaining fruit, which meets the standards for export or sale, continues through the processing system. The hands may be broken down further into smaller clusters, sometimes called clusters or fingers, depending on market requirements. Workers use knives to divide the hands, creating smaller groups of bananas that will be packaged together. This cutting is done carefully to avoid damaging the fruit, while creating uniform clusters that will pack well and present attractively when they reach stores. The clusters are typically still attached at their stems, maintaining their natural grouping. The processed banana clusters are moved to washing stations where they receive a more thorough cleaning. They may pass through tanks of water that contain mild cleaning solutions designed to remove any remaining sap, dirt, or other residues. The water is kept at a temperature that is appropriate for the fruit, neither too cold nor too warm, to avoid shocking the bananas or affecting their quality. The clusters move through the washing system on conveyor belts or are hand-dipped by workers, depending on the setup of the particular packing facility. After washing, the banana clusters are rinsed with clean water to remove any traces of the cleaning solution. The fruit emerges wet and clean, ready for the next stage of processing. Excess water drips away as the clusters are moved to drying areas or placed on surfaces where air can circulate around them. Some facilities use fans to speed the drying process, while others simply allow the fruit to air dry in well-ventilated spaces. The goal is to remove surface moisture while keeping the fruit at an appropriate temperature. Once the clusters are dry, they are ready for treatment to help preserve their quality during the long journey ahead. A common treatment involves applying a fungicide solution that helps prevent the development of crown rot, a fungal disease that can affect the cut stem ends where the clusters were separated from the hands. The clusters may be dipped in this solution or it may be applied by spraying. The treatment is light and carefully controlled, using only the amount needed to provide protection without affecting the fruit itself. The treated clusters are then sorted by quality and size. Workers examine each cluster and group them according to established grades. The highest quality fruit with uniform size and perfect skin condition goes into one category. Other grades accommodate fruit that is acceptable but may have minor variations in size or slight blemishes that do not affect the eating quality but may affect the appearance. This sorting ensures that each package or box will contain fruit of similar quality. Packing begins once the fruit has been sorted. Cardboard boxes are assembled and lined with plastic bags or liners that will protect the fruit during shipping. Workers place the banana clusters into these boxes with careful attention to arrangement. The clusters are positioned to minimize movement during transport, as shifting fruit can lead to bruising. The boxes are filled to an appropriate weight, neither too light nor too heavy, following standards that have been established for shipping and handling. Some banana clusters are packed in special plastic bags before being placed in boxes. These bags provide an additional layer of protection and can help manage the atmosphere around the fruit during storage and transport. The bags may be perforated to allow some air exchange while still providing a protective barrier. Workers slip the clusters into these bags carefully, ensuring that the fruit is not compressed or damaged in the process. The filled boxes are closed and sealed, often with tape or staples that keep the lids secure during handling and transport. Labels are applied to the outside of each box, indicating information about the contents, the origin of the fruit, the grade, and other relevant details. These labels help ensure that the fruit can be tracked through the supply chain and that handlers know how to treat the boxes appropriately. Barcodes or other tracking systems may also be applied, allowing for digital tracking as the fruit moves from the plantation to its final destination. The packed boxes are stacked on pallets, creating stable units that can be moved efficiently with forklifts or pallet jacks. The stacking is done carefully to avoid crushing the boxes on the bottom, with consideration given to the weight distribution and the height of the stack. The pallets are then moved to refrigerated storage areas where the fruit will be kept at controlled temperatures until it is ready to be loaded for transport. The storage rooms are maintained at specific temperatures that slow the ripening process without causing damage to the fruit. Bananas are sensitive to cold, and temperatures that are too low can cause chilling injury that affects quality. The storage temperature is carefully managed to keep the fruit in a green, unripe state while avoiding any harm. The humidity in these rooms is also controlled, as too much moisture can encourage fungal growth while too little can cause the fruit to lose water and shrivel. While the bananas wait in cold storage, preparations are made for their transport. Refrigerated shipping containers are positioned and prepared to receive the fruit. These containers are essentially large refrigerated boxes that can maintain controlled temperatures throughout a long journey. They are equipped with refrigeration units that run on electricity, either from external power sources when stationary or from generators when in transit. The containers are inspected to ensure they are clean and functioning properly before any fruit is loaded. When the time comes to load the containers, workers use forklifts to transport the pallets of packed bananas from the storage rooms to the waiting containers. The pallets are positioned inside the containers with attention to air circulation and weight distribution. The refrigeration system must be able to maintain a uniform temperature throughout the container, so the pallets cannot be packed so tightly that air cannot flow between them. Spaces are left to allow cold air to circulate and keep all the fruit at the proper temperature. The containers are filled systematically until they reach their capacity. Each container holds many boxes of bananas, representing the harvest from numerous plants across the plantation. Once a container is fully loaded, its doors are closed and sealed. The refrigeration unit is set to the appropriate temperature and monitoring systems are activated to track conditions inside the container throughout the journey. The sealed container is now a controlled environment, protecting the fruit from external temperature fluctuations and maintaining the conditions needed to keep the bananas in their green, unripe state. The loaded containers are transported from the plantation to a port facility. This journey may be short or long depending on the location of the plantation relative to shipping ports. Large trucks equipped to pull the refrigerated containers navigate roads that lead from rural agricultural areas toward coastal shipping facilities. The containers remain connected to power sources during transport to ensure continuous refrigeration. The trucks move steadily, delivering their cargo to the docks where ships wait to carry the fruit across oceans. At the port, the containers are unloaded from the trucks and organized in staging areas. Massive cranes lift the containers and stack them in organized rows, creating temporary storage yards where containers await their turn to be loaded onto ships. The refrigerated containers remain plugged into power sources at the port, maintaining the cold temperatures that keep the bananas in their unripe state. Port workers monitor the containers, checking that refrigeration systems are functioning and that the fruit inside remains at the proper temperature. Cargo ships designed to carry refrigerated containers arrive at the port and dock at designated berths. These ships have the capacity to carry hundreds or even thousands of containers, along with the electrical systems needed to power the refrigeration units during the voyage. The ships are loaded systematically, with cranes lifting containers from the dock and lowering them into position on the ship. The process is methodical and precise, with each container placed according to a carefully planned loading scheme that considers weight distribution and destination. The containers of bananas are stacked in holds below deck and on deck above, secured in place with locking mechanisms that prevent shifting during the ocean voyage. Once positioned, each container is connected to the ship's electrical system, so its refrigeration unit can continue operating. The ship's crew monitors these connections and the temperature within the containers, ensuring that the refrigeration systems function properly throughout the voyage. The bananas, packed in their boxes, stacked on pallets, enclosed in containers, remain in their controlled environment as the ship prepares to depart. The ship leaves port when loading is complete and all preparations have been made. It moves slowly at first, navigating the harbor and coastal waters with care, then increases speed as it reaches open ocean. The voyage may last days or weeks depending on the distance between the origin port and the destination. Throughout this time, the ship maintains its course, the engines run steadily, and the refrigeration systems in the containers continue their work, keeping the bananas cold and green. The ocean surrounds the ship in all directions, vast and deep. Waves move across the surface, their size varying with weather conditions and wind. The ship rises and falls with these waves, moving through the water on its predetermined route. Inside the containers, the bananas remain stable, protected from the motion of the sea by their packaging and the secure stacking of the boxes on pallets. The controlled temperature inside the containers remains constant despite the changing conditions outside. Days pass as the ship crosses the ocean. The sun rises and sets, marking time while the vessel continues its journey. The crew maintains the ship, monitors its systems, and ensures that the refrigerated containers continue to function properly. Regular checks confirm that temperatures remain within acceptable ranges and that no problems have developed. The voyage is routine for ships designed for this purpose, one of many similar journeys that occur constantly across the world's oceans, moving food and goods from places of production to places of consumption. Eventually, the ship approaches its destination port. The coastline appears on the horizon, and the ship reduces speed as it enters coastal waters. Pilots may board to guide the ship through harbor channels to the assigned berth. The ship docks and lines are secured, connecting the vessel to the land infrastructure that will enable unloading. The containers have reached the next stage of their journey, having successfully crossed the ocean while maintaining the controlled conditions necessary to preserve the bananas in their green state. Unloading begins once the ship is secured at the dock. The same type of large cranes that loaded the containers at the origin port now lift them from the ship. One by one, the containers are raised from their positions, swung over the side of the ship, and lowered onto trucks or directly onto the dock. The process is systematic and continuous, moving through the containers in an organized sequence. The containers holding bananas are handled with no special drama, simply moved as part of the larger cargo being unloaded from the ship. The containers are transported from the dock to ripening facilities or distribution centers. These facilities are specialized warehouses designed to handle produce that requires controlled ripening. The containers arrive on trucks and are positioned at loading docks where they can be unloaded. The doors of the containers are opened and the pallets of boxed bananas are removed using forklifts. The fruit is still green, still firm, still in the unripe state it has maintained throughout its journey from the plantation. Inside the ripening facility, the boxes of bananas are moved into ripening rooms. These rooms are sealed chambers where temperature, humidity, and atmospheric composition can be precisely controlled. The boxes are stacked on racks or left on pallets, arranged to allow air circulation around all the fruit. The rooms are large enough to hold many boxes, representing the output from numerous plants and the harvest from extensive plantation areas. Once the rooms are loaded with fruit, the doors are closed and the ripening process begins. The ripening process is initiated by introducing ethylene gas into the rooms. Ethylene is a natural plant hormone that triggers ripening in bananas and many other fruits. In nature, bananas produce small amounts of ethylene as they mature, which gradually triggers the ripening process. In the ripening facility, ethylene is introduced deliberately to start ripening in a controlled and uniform way. The gas is distributed throughout the room, reaching all the fruit and signaling the bananas to begin their transformation from starch to sugar. The concentration of ethylene in the ripening room is carefully controlled. Too much can cause the fruit to ripen too quickly or unevenly, while too little may not trigger ripening effectively. The facility operators monitor the ethylene levels and adjust them as needed to achieve the desired rate of ripening. The gas is typically applied for a period of time. Then the room is ventilated to remove excess ethylene before being sealed again with controlled air composition. Temperature in the ripening rooms is also carefully managed. The rooms are kept at temperatures that support the ripening process, warm enough to allow the biochemical changes to proceed but not so warm that the fruit deteriorates or ripens too rapidly. The temperature may be adjusted during the ripening cycle, starting at one temperature and gradually changing to fine-tune the process. Humidity is maintained at levels that prevent the bananas from drying out while avoiding excess moisture that could encourage mold growth. Inside each banana, invisible changes begin as the ethylene signal is received by the fruit tissue. Enzymes become active, starting to break down the starch molecules that have been stored in the fruit. The starch is converted to simpler sugars, primarily sucrose, glucose, and fructose. As the sugar content increases, the banana becomes sweeter. This conversion is gradual, happening over the course of several days as the ripening process progresses. The skin of the banana begins to change color as ripening proceeds. The green color comes from chlorophyll, and as ripening advances, this chlorophyll breaks down. As the chlorophyll degrades, other pigments become visible. Yellow carotenoid pigments that were present all along but masked by the green chlorophyll now show through, giving the banana skin its characteristic yellow color. The change is gradual, starting at the ends and edges of the fruit and spreading across the skin until the entire banana is yellow. The texture of the fruit changes as well. The firm, dense flesh of the green banana becomes softer as the starches convert to sugars and as changes occur in the cell walls of the fruit tissue. The pectin in the cell walls is modified by enzymes, causing the structure to soften. The banana becomes easier to peel as the skin separates more readily from the flesh. The flesh itself becomes creamy and smooth, the texture that people expect when they eat a ripe banana. The ripening process is monitored carefully by facility operators. They check the fruit regularly, observing the color development and sometimes testing samples to assess the stage of ripening. Different markets and customers may want bananas at different stages of ripeness, so the ripening is tailored to meet specific requirements. Some fruit may be shipped while still showing some green, intended for customers who prefer firmer bananas or who want fruit that will continue ripening at home. Other fruit is ripened more fully, reaching a bright yellow color with perhaps the first appearance of brown speckles that indicate peak ripeness. When the bananas have reached the desired stage of ripeness, they are removed from the ripening rooms. The temperature in the rooms may be lowered to slow or stop further ripening, preserving the fruit at the current stage. The boxes are loaded onto trucks for distribution to retail outlets, wholesale markets, or other customers. The journey that began in a tropical plantation has now brought the fruit to within a short distance of the people who will eventually eat it. The trucks carrying the ripened bananas travel to grocery stores, supermarkets, and other retail outlets. These vehicles may be refrigerated to maintain appropriate temperatures during transport, preventing the bananas from ripening too quickly or being damaged by heat. The routes are planned to deliver fruit efficiently to multiple locations, with trucks making stops at various stores to unload portions of their cargo. The drivers and handlers continue to treat the fruit with care, aware that bananas are susceptible to bruising even when fully ripe. At the retail store, the boxes of bananas are received at loading docks or delivery areas. Store employees unload the boxes and transport them to the produce department. The bananas are unpacked from their boxes and arranged for display. The yellow fruit is placed in bins or on racks where customers can see and access it easily. The display is replenished regularly as bananas are purchased, with employees bringing fresh fruit from storage areas in the back of the store as needed. The produce section of the grocery store is kept at temperatures that are comfortable for shoppers, while still being cool enough to slow the continued ripening of fruits and vegetables. The bananas sit under lights that make their yellow color appear bright and appealing. They are often displayed near other tropical fruits or in a prominent location within the produce section, as bananas are among the most commonly purchased fruits in many parts of the world. The display is maintained throughout the day, with bruised or overripe fruit removed and replaced with better specimens. Customers enter the store on their own schedules, arriving throughout the day to shop for groceries. They move through the aisles with carts or baskets, selecting items they need or want. When they reach the produce section, many will pause at the banana display. The bananas are familiar, recognizable, affordable, and versatile. Shoppers examine the fruit, looking at the color to judge ripeness. Some prefer bananas that are still slightly green, knowing these will keep longer at home. Others choose fruit that is fully yellow or even showing brown spots, preferring bananas that are ready to eat immediately. A person reaches out and selects several bananas from the display. They may pick them individually or choose a small cluster that is still attached at the stems. The bananas are placed in the shopping cart along with other items. The shopper continues through the store, gathering what they need, eventually making their way to the checkout area. The bananas are placed on the conveyor belt along with other purchases, and the cashier weighs them or scans them to determine the price. The fruit is placed in a bag or directly into a reusable shopping bag that the customer has brought. The journey home is brief compared to the long distance the bananas have traveled. The customer carries their groceries from the store to their car, drives home, and brings the bags inside. The bananas are removed from the bag and placed on a kitchen counter or in a fruit bowl. They sit at room temperature, exposed to the air and light of the home environment. The ripening process continues slowly, as it will until the fruit becomes too ripe to enjoy or until it is eaten. In the home, the bananas become part of the daily environment. They might sit undisturbed for a day or several days, depending on the household's eating habits. The yellow skin may develop more brown spots as time passes, indicators that the sugars inside are increasing and the fruit is becoming sweeter and softer. These spots are not defects but rather signs of the natural progression of ripening, often appearing on bananas that have reached peak flavor. Someone in the household decides to eat a banana. They pick one from the bunch, feeling its weight in their hand. The fruit is curved and smooth, easy to hold. The skin is still intact, protecting the edible flesh inside. To open the banana, the person finds the stem end and pulls back on one section of the peel. The skin separates readily, pulling away from the flesh in strips. The characteristic 3-part or sometimes 4-part division of the peel reveals the pale fruit inside. The flesh of the banana is creamy in color, smooth in texture. It is firm enough to hold its shape but soft enough to bite into easily. The fruit has no seeds to avoid, no core to remove, no preparation needed beyond the simple peeling. The person takes a bite, and the sweet flavor fills their mouth. The taste is mild and pleasant, with a sweetness that comes from the sugars that developed during ripening, sugars that were once starches stored in green fruit hanging from a plant in a distant tropical location. The rest of the banana is consumed in a few more bites. The peel is discarded, perhaps composted or thrown away depending on the household's practices. The simple act of eating this banana is complete, but it represents the culmination of a long process. The fruit that was grown in soil enriched by rain and sun, that developed on a plant that took months to mature, that was harvested by hand and processed with care, that traveled across oceans in controlled conditions, that was ripened deliberately and distributed efficiently, has now fulfilled its purpose. It has provided nourishment and a moment of simple satisfaction to someone who may never have thought about the journey it took to arrive at that moment. Back at the plantation where this particular banana originated, the cycle continues. New plants are growing from the suckers that developed at the bases of harvested plants. Young shoots are emerging from corms in the soil, pushing upward toward the light. Leaves are unfurling, broad and green, capturing sunlight and converting it to energy. More flower buds are forming inside pseudostems, preparing to emerge and develop into new bunches of fruit. The work of growing and harvesting continues day after day, week after week, maintaining the supply of fruit that travels around the world. The plantation extends across land that was once forest or grassland, transformed through human effort into organized rows of banana plants. The soil has been prepared and enriched. The plants have been established from suckers or tissue culture, and systems have been put in place to provide water when rain is insufficient. The plantation represents a long-term investment in agriculture, requiring ongoing care and management to remain productive. Workers live in nearby communities, traveling to the plantation for their shifts, performing tasks that follow the rhythms of plant growth and fruit production. The same workers who harvest bunches also monitor the plants for signs of disease or pest problems. Banana plants can be affected by various organisms that interfere with growth or damage the fruit. Fungal diseases can attack leaves or roots. Bacterial diseases can cause rotting of tissues, and insects can feed on plants or transmit diseases. The workers observe the plants closely, looking for discoloration, unusual spots, wilting, or other symptoms that indicate a problem. Early detection allows for intervention before issues spread widely. When problems are identified, decisions are made about how to respond. Some issues can be managed through cultural practices, such as removing affected leaves or improving drainage to reduce conditions that favor disease. Other problems may require the application of treatments designed to control pests or diseases. These treatments are applied carefully, following guidelines that aim to protect both the health of the plants and the safety of workers and the environment. The goal is to maintain healthy, productive plants while minimizing negative impacts. The plantation operates within a larger agricultural landscape. Other farms may be nearby, growing different crops or raising livestock. Roads connect the plantation to towns and cities where workers live and where businesses provide supplies and services. The plantation may be part of a cooperative or owned by a company that manages multiple growing locations. Regardless of ownership structure, the daily work of growing bananas continues, driven by the demand for fruit in markets near and far. Water management is a constant consideration at the plantation. Bananas require substantial amounts of water throughout their growing cycle, and ensuring adequate water supply is essential for good yields. In regions with reliable rainfall, the rain may provide most or all of what the plants need. In drier areas or during dry seasons, irrigation becomes necessary. Water may be drawn from rivers, wells, or reservoirs and distributed through pipe systems that run along the rows of plants. Drip irrigation delivers water directly to the root zone of each plant, while sprinkler systems spread water over broader areas. The soil in the plantation is a living system, home to countless microorganisms that play roles in nutrient cycling and plant health. Bacteria and fungi in the soil break down organic matter, releasing nutrients that plants can absorb. Earthworms and other soil organisms help to aerate the soil and mix organic material into it. The health of the soil community contributes to the health of the banana plants, and good agricultural practices aim to maintain or enhance soil quality over time. Organic matter is added to the soil periodically to maintain fertility. This might come from composted plant material, animal manures, or other organic sources. The organic matter improves soil structure, helps the soil retain water and nutrients, and feeds the soil organisms that contribute to nutrient availability. In some plantations, the dead leaves and old pseudostems from harvested banana plants are chopped and left on the ground to decompose, returning their nutrients to the soil and creating a protective mulch layer. The spacing between plants is calculated to balance several factors. Plants need enough space to develop fully without being crowded by their neighbors, but closer spacing allows more plants per area and potentially higher total production. The optimal spacing depends on the variety of banana being grown, the soil fertility, the climate, and other local conditions. Once established, the spacing remains relatively constant, though over time suckers may be managed to maintain the desired plant density. Throughout the year, the plantation experiences variations in weather that affect plant growth and fruit production. The tropical climate that bananas require is generally warm and humid, but there can still be variations in rainfall, temperature, and other factors. Wet seasons bring abundant rain that promotes growth, while drier periods may slow growth if irrigation is not provided. Temperature variations are usually modest in tropical regions, but unusually cool or hot periods can affect plant physiology and fruit development. Storms can impact the plantation when they occur. Strong winds can damage leaves or even topple plants if they are severe enough. Heavy rain can lead to waterlogging if drainage is inadequate. The workers and managers monitor weather forecasts and prepare as best they can for challenging conditions. After storms pass, they assess any damage and take steps to recover, such as propping up plants that have been pushed over or removing leaves that have been severely damaged. The export of bananas from tropical growing regions to markets in temperate climates is a massive global enterprise. Millions of tons of bananas are shipped each year, traveling across oceans and continents to reach consumers. The infrastructure that makes this possible includes plantations, packing facilities, ports, ships, ripening centers, and distribution networks. Each component must function effectively for the system to work, delivering fresh fruit to stores where people shop. The banana itself is well suited to this long-distance trade. Unlike some fruits that are extremely delicate or that ripen very quickly, bananas can be harvested green and will ripen later under controlled conditions. This characteristic makes it possible to ship them over long distances and time the ripening so that they reach consumers at the desired stage. The ability to control ripening through temperature management and ethylene application is central to the banana trade as it exists today. Different varieties of bananas exist, though most of the bananas in international trade belong to a single variety called Cavendish. This variety became dominant in the global banana trade because of its qualities, including good yield, acceptable flavor when ripe, and relatively good shipping characteristics. The plants produce large bunches of uniformly sized fruit that meet market expectations. Despite the existence of many other banana varieties with different flavors and characteristics, the Cavendish has become the standard for export bananas. Growing regions for export bananas are concentrated in tropical areas of Central and South America, parts of Africa, Southeast Asia, and some Caribbean islands. Each region has its own characteristics in terms of climate, soil, and agricultural practices, but all share the warm, humid conditions that banana plants require. The fruit from these regions enters global trade networks, with some production destined for nearby markets and other production shipped to distant continents. The price paid for bananas reflects many factors including production costs, shipping expenses, ripening and distribution costs, and retailer margins. Bananas are often among the least expensive fruits available in temperate climate markets, despite having traveled thousands of miles from where they were grown. This low price is made possible by the scale of production, the efficiency of the shipping and ripening infrastructure, and competitive pressures in the global market. For consumers, the result is year-round availability of affordable fresh fruit. For the people who work in banana plantations, the conditions and compensation vary considerably depending on location, employer, and local labor regulations. The work is physically demanding, involving tasks such as cutting heavy bunches, carrying fruit, and performing repetitive motions throughout the day. The work is often performed in hot, humid conditions that can be challenging. Efforts to improve working conditions and ensure fair wages are ongoing in the banana industry, with various certification programs and labor agreements aimed at promoting better practices. Environmental considerations in banana production include the use of pesticides and fertilizers, water consumption, and the impact on local ecosystems. Conventional banana plantations typically use chemical inputs to manage pests and diseases and to maintain soil fertility. These inputs can have environmental effects if not managed carefully, potentially affecting water quality, soil health, and non-target organisms. Organic banana production uses different approaches, relying on cultural practices and approved organic inputs rather than synthetic chemicals. though organic production presents its own challenges and typically results in lower yields per area. The long-term sustainability of banana production faces challenges including disease pressure, climate change, and the need to maintain soil health. Banana plants are susceptible to various diseases, some of which have devastated production in the past. A disease called Panama disease or fusarium wilt has affected banana production for over a century, and a new strain of this disease is currently spreading through production areas, threatening the Cavendish variety that dominates the global trade. Finding resistant varieties or developing other solutions is an ongoing concern for the banana industry. Climate change may affect banana production through changes in temperature and rainfall patterns, increased frequency of extreme weather events, and shifts in the distribution of pests and diseases. Bananas require specific conditions to grow well, and significant changes in climate could affect where they can be produced successfully. Adaptation strategies might include developing varieties that are more tolerant of changed conditions, adjusting management practices, or shifting production to new areas that become suitable as climates change. Despite these challenges, banana production continues and the fruit remains widely available in markets around the world. The systems that support this availability have developed over decades and continue to evolve. Improvements in varieties, growing practices, shipping technology, and ripening techniques have all contributed to making bananas accessible to consumers far from where they are grown. The result is that people in many parts of the world can buy fresh bananas any time of year, a degree of availability that previous generations could not have imagined. The banana that a person selects from a store display is the product of both natural processes and human management. The plant that produced it grew according to its biological nature, following patterns that have existed for millennia. The leaves captured sunlight through photosynthesis, the roots absorbed water and nutrients from soil, and the fruit developed as the plant's reproductive structure, modified over time by human selection. At the same time, the banana is also a product of agricultural systems, international trade, and modern logistics that brought it from a tropical plantation to a store thousands of miles away. In the kitchen, bananas serve many purposes beyond being eaten fresh. They can be sliced and added to breakfast cereals or yogurt, providing natural sweetness and soft texture. They can be mashed and incorporated into baked goods, where they add moisture and subtle flavor to breads, muffins, and cakes. Bananas can be frozen and blended into smoothies, or cooked in various ways for desserts. The versatility of the fruit makes it useful in many culinary contexts, and its mild flavor pairs well with many other ingredients. Overripe bananas, those that have developed extensive brown spots or even turned mostly brown, are still valuable rather than being wasted. The increased sweetness and softer texture of very ripe bananas make them ideal for baking. Banana bread is a common way to use fruit that has passed the stage where most people would enjoy eating it fresh. The bananas are mashed and mixed with flour, eggs, and other ingredients, then baked into a moist, sweet bread that can be enjoyed for days. This use of overripe fruit helps reduce waste and extracts value from bananas at all stages of ripeness. The peel of the banana, which is removed before eating, represents a significant portion of the fruit's total mass. In most households, the peel is discarded, but it contains nutrients and organic matter that can be valuable. Some people compost banana peels, allowing them to decompose and return their nutrients to soil that might be used for growing other plants. In agricultural settings, banana plant waste, including peels and old plant material, can be composted on a larger scale and used to improve soil in the plantation or other growing areas. The banana industry supports livelihoods for millions of people around the world. These include farm workers who tend the plants and harvest the fruit, workers in packing facilities who process and prepare the fruit for shipping, dock workers who load and unload shipping containers, ship crews who transport the fruit across oceans, workers in ripening facilities who manage the ripening process, truck drivers who deliver the fruit to stores, and retail workers who display and sell the fruit to customers. Each of these roles is part of the larger system that makes bananas available to consumers. In producing countries, banana plantations can be significant economic assets, providing employment and generating income that supports local economies. The export of bananas brings in foreign currency and can contribute to national economies. At the same time, the concentration of land in banana production can raise questions about land use, as land devoted to banana plantations cannot be used for other purposes such as growing food for local consumption or maintaining natural ecosystems. These trade-offs are part of the broader questions about how agricultural land is used and who benefits from different choices. For consumers, the banana offers convenience and nutrition at a low price. A banana comes in its own natural packaging that protects the fruit until it is ready to be eaten. No washing is required before eating, no utensils are needed, and no preparation beyond peeling is necessary. The fruit provides carbohydrates for energy, vitamins including vitamin C and vitamin B6, minerals such as potassium and magnesium, and dietary fiber. While not all nutrients are present in large amounts, the banana contributes to overall dietary intake as part of a varied diet. The global nature of the banana trade means that fruit available in stores comes from various sources depending on season and availability. A consumer in North America might buy bananas that were grown in Ecuador, Guatemala, Costa Rica, or another Central or South American country. A consumer in Europe might buy bananas from West Africa or the Caribbean. The source of the fruit is often not visible to the consumer, who simply sees yellow bananas in the store without knowing their specific origin. Labels may indicate country of origin, but the day-to-day shopping experience typically does not emphasize where particular bananas were grown. Transportation networks must function smoothly for bananas to reach consumers in good condition. Delays in shipping can affect fruit quality, as can problems with refrigeration systems. Coordination between different parties in the supply chain, from plantation to retailer, is necessary to ensure that fruit moves efficiently and arrives when expected. Modern information systems help track shipments and manage inventory, allowing retailers to maintain appropriate stock levels and minimize both shortages and excess inventory that might spoil. The ripening centers that receive green bananas and ripen them in controlled conditions represent a specialized part of the supply chain. These facilities have rooms that can be sealed and where atmosphere can be carefully managed. The knowledge needed to ripen bananas consistently and achieve desired results has been developed through experience and research. Operators of these facilities understand how temperature, ethylene concentration, humidity, and time interact to determine the outcome. They adjust conditions based on the starting condition of the fruit, the variety, and the specifications they need to meet. Quality control is important throughout the banana supply chain. At the plantation, workers sort fruit and reject pieces that do not meet standards. At packing facilities, additional sorting occurs to ensure that only acceptable fruit is packed for shipping. At ripening centers, the fruit is checked upon arrival and monitored during ripening. At retail stores, employees remove damaged or overripe fruit from displays. Despite all these quality control measures, some variation in fruit quality inevitably reaches consumers, as bananas are natural products that vary in size, shape, and characteristics. The shelf life of ripe bananas is limited. Once fully yellow, bananas will continue to ripen over several days, developing brown spots and eventually becoming too soft for most people's preferences. This limited shelf life means that retailers must manage inventory carefully, bringing in new shipments regularly and removing fruit that has become overripe. The challenge is to maintain sufficient stock to meet customer demand while minimizing waste from fruit that passes its prime before being sold. Some retailers have responded to the challenge of banana ripeness by offering fruit at different stages. A store might display bananas ranging from slightly green to fully yellow, allowing customers to choose based on their preferences and when they plan to eat the fruit. This approach recognizes that different customers have different needs, with some wanting fruit they can eat immediately and others preferring fruit that will last longer at home. The familiarity of bananas in many markets means that they are taken for granted by most consumers. The fruit is simply there in the store, available and affordable, a routine purchase that requires little thought. This familiarity masks the complexity of the systems that make this availability possible. Few consumers think about the plantation workers who harvested the fruit, the journey across the ocean, or the ripening process that transformed green fruit into the yellow bananas in the store. The banana has become ordinary through the extraordinary efforts required to produce and distribute it. Yet the ordinariness of the banana is itself remarkable when considered historically. For most of human history, bananas were available only in tropical regions where they grew. People in temperate climates never encountered bananas, as there was no way to transport the perishable fruit over long distances. The development of refrigerated shipping and the organization of global supply chains in the 20th century changed this completely, making a tropical fruit available year-round in places far from where it can be grown. This transformation of the banana from an exotic rarity to an everyday staple is a relatively recent development in historical terms. The banana plant continues its growth cycle in the plantation even as fruit from previous cycles is being consumed. The intergenerational nature of banana propagation through suckers means that plants descended from earlier plantings continue the work of producing fruit. A plantation established decades ago may still be producing from plants that are the descendants of the original stock, propagated vegetatively generation after generation. This continuity links the fruit purchased today to plants established long ago, to decisions made about which varieties to grow and how to manage the plantation. Seasonal variations affect banana production, though the impact of seasons is less dramatic in tropical regions than in temperate zones. Drier and wetter periods influence plant growth and fruit development. Temperature variations, while modest, can affect the rate of growth and the time required for fruit to mature. These seasonal influences mean that production is not completely uniform throughout the year, though modern plantations aim to maintain relatively steady output by managing the timing of when plants flower and produce fruit. The relationship between humans and bananas extends back thousands of years. Bananas were among the earliest plants domesticated by humans, with cultivation beginning in Southeast Asia in prehistoric times. Over centuries and millennia, people selected and propagated varieties with desirable characteristics, gradually transforming wild bananas with large seeds into the seedless fruit that we know today. This long history of cultivation and selection has created the diversity of banana varieties that exist, though only a few varieties dominate global trade. Wild bananas still exist in some forest areas, different from the cultivated varieties in having large seeds and less edible flesh. These wild species represent the ancestral forms from which cultivated bananas were developed through human selection. The wild species also represent genetic diversity that could potentially be valuable for developing new varieties in the future, particularly varieties with resistance to diseases or improved tolerance of different growing conditions. The banana in a fruit bowl at home sits quietly as time passes. The ripening process continues slowly, with enzymes breaking down remaining starches and further softening the fruit tissue. The skin develops more brown spots, which appear first as small speckles and gradually enlarge and merge as ripening progresses. Inside the fruit, the flesh becomes sweeter and softer, the changes accumulating day by day. The banana at this stage is at or near peak ripeness, offering maximum sweetness and a very soft, creamy texture. If the banana is not eaten during this period, it will continue to ripen beyond the stage that most people prefer. The brown spots on the skin will spread until much or most of the skin is brown. The fruit inside will become very soft, almost mushy, and may begin to develop off flavors as the ripening process progresses toward deterioration. At this stage, the banana is still edible and can be used in baking or smoothies where the very soft texture is not a problem. but most people would not choose to eat it fresh. Eventually, if still not eaten or used, the banana will begin to spoil. Microorganisms that were unable to penetrate the healthy fruit find entry points where the skin has split or where the fruit has become damaged. Molds may begin to grow on the skin or at damaged areas. The fruit tissue breaks down further, and the banana loses the characteristics that made it desirable as food. At this point, it is no longer fit for consumption and will typically be discarded or composted. The cycle from green fruit to spoiled fruit can take 1 to 2 weeks or somewhat longer depending on storage conditions. Cooler temperatures slow ripening and extend the time before spoilage occurs, while warmer temperatures accelerate all the processes. This is why bananas are stored at cool temperatures during shipping and at ripening facilities, but then kept at room temperature in stores and homes, where some continued ripening is acceptable or even desired to ensure fruit reaches peak ripeness. Back at the plantation, the cycle of growth and production continues without pause. As some plants are harvested, others are flowering, and still others are growing vegetatively, producing the leaves and pseudostem that will eventually support a bunch of fruit. The suckers that will become the next generation are developing at the bases of mature plants, ensuring continuity of production. This ongoing cycle means that the plantation can produce fruit throughout the year, though production rates may vary somewhat with seasonal conditions. The long-term management of a banana plantation requires attention to many factors. Soil fertility must be maintained through addition of organic matter and nutrients. Water must be supplied in appropriate amounts at appropriate times. Pests and diseases must be monitored and managed to prevent damage to plants or fruit. The timing of sucker development and removal must be managed to maintain appropriate plant density. All of these tasks require knowledge and labor, and the success of the plantation depends on how well they are performed. Some plantations are managed intensively with high inputs of fertilizers, pesticides, and irrigation water, aiming for maximum production per unit of land. Other plantations use less intensive approaches, accepting lower yields in exchange for reduced costs and potentially lower environmental impacts. The choice of management approach depends on many factors, including economic considerations, environmental values, regulatory requirements, and market demands for different types of bananas, such as organic versus conventional. The global banana industry faces ongoing challenges that will shape its future. Disease pressures, particularly from Panama disease, threaten the Cavendish variety that dominates international trade. Climate change may alter the suitability of current growing regions and create pressure to adapt varieties or practices. Consumer preferences may shift, potentially increasing demand for organic bananas or for varieties with different flavors or characteristics. Labor issues and demands for fair treatment of workers continue to be important considerations. How the industry responds to these challenges will determine what banana production looks like in coming decades. Research continues on developing new banana varieties with improved characteristics. Scientists work on breeding or genetically modifying bananas to resist diseases, tolerate different environmental conditions, or have other desirable traits. This research is complex because most cultivated bananas are sterile and cannot reproduce sexually, making traditional breeding difficult. Alternative approaches using tissue culture and genetic modification offer possibilities but also raise questions about acceptance by consumers and regulators. The development of new varieties that can replace Cavendish if it becomes unviable due to disease is particularly urgent. Meanwhile, in kitchens and dining rooms around the world, bananas continue to be eaten fresh, added to various dishes, or used in cooking and baking. The fruit has become so integrated into diets and food cultures that it is hard to imagine its absence. Children grow up eating bananas as one of their first solid foods. Athletes eat them for quick energy. Busy people grab them as convenient snacks. The banana has found a place in modern life that reflects both its inherent qualities as a fruit and the systems that make it widely available. The journey of the banana from plant to consumption involves transformation at every stage. The transformation from corm to shoot to plant with broad leaves represents growth and development driven by biological processes. The transformation from flower to green fruit to ripe yellow fruit represents maturation and ripening, guided by plant hormones and environmental conditions. The transformation from fruit in a plantation to product in a store represents the application of human systems of agriculture, logistics, and commerce. Each transformation is necessary for the banana to fulfill its role as food. In the plantation, the soil that supports banana growth is itself the product of long processes. Weathering of rock over geological time created the mineral particles that make up soil. Decomposition of organic matter from plants and other organisms added the organic component that enriches soil and supports soil life. The particular characteristics of the soil at any plantation location reflect the parent rock material, the climate, the vegetation that grew there in the past, and how the land has been used. Good banana production requires soil that can hold adequate moisture and nutrients while also draining well enough to prevent waterlogging. The water that banana plants require falls as rain or is supplied through irrigation. The water that falls as rain comes from the ocean, evaporated by the sun's energy, carried in the atmosphere as water vapor, and released when conditions cause condensation and precipitation. This water cycle is global in scale, moving vast quantities of water from ocean to atmosphere to land and back to ocean. The banana plant intercepts a tiny fraction of this flow, drawing water from soil where rain has deposited it, using it for photosynthesis and cell growth, and releasing some back to the atmosphere through transpiration from leaf surfaces. The energy that drives plant growth comes ultimately from the sun. Nuclear fusion in the sun's core releases energy that radiates outward, with a small portion reaching Earth as sunlight. Banana leaves capture some of this energy through photosynthesis, using it to power the chemical reactions that build sugars from carbon dioxide and water. These sugars provide the energy and carbon building blocks for all the plant's growth. The fruit that eventually develops contains energy that can be traced back through these processes to sunlight falling on leaves in the plantation. The carbon that makes up most of the mass of the banana plant and fruit comes from carbon dioxide in the air. The air around the plantation contains about 400 parts per million of carbon dioxide, a trace gas that is nevertheless essential for plant growth. The banana plant takes in this carbon dioxide through tiny pores on the leaf surfaces and uses it in photosynthesis to build sugars and eventually all the other organic molecules that make up plant tissues. The carbon that was in the air becomes part of the plant structure, stored temporarily before being released back to the atmosphere when the plant material decomposes or is burned. The workers who tend the banana plants and harvest the fruit are themselves sustained by food, including perhaps bananas. The energy they expend in their work comes from the food they eat, which ultimately derives from photosynthesis in plants, whether those plants are bananas or rice or wheat or any of the other crops that provide human food. The human system of agriculture is thus a way of organizing plant growth to serve human needs, directing the energy flow from sunlight through plants to people in ways that support large human populations. The ships that carry bananas across oceans are powered by engines that burn fuel, releasing energy that was stored in petroleum millions of years ago. That energy also originated with sunlight, captured by ancient organisms, and stored in organic molecules that were buried and transformed over geological time into the fossil fuels that modern civilization uses. The energy embodied in transporting bananas from tropical plantations to distant markets is substantial, reflecting the energy-intensive nature of modern food systems that move products around the globe. The refrigeration systems that keep bananas at controlled temperatures during shipping and ripening require electrical energy to operate. This electricity may come from various sources including fossil fuels, nuclear power, or renewable sources such as hydroelectric, wind, or solar power. Whatever the source, the electricity represents energy that is used to remove heat from the refrigerated spaces, maintaining the cool temperatures that prevent premature ripening. The energy input required for this refrigeration is part of the total energy cost of delivering bananas to consumers. When someone eats a banana, they are consuming the energy that was captured by the plant's leaves and stored in the fruit as sugars and starches. The human digestive system breaks down these carbohydrates, releasing the energy they contain and making it available to power the body's activities. The banana thus serves as an energy transfer mechanism, moving energy from sunlight to human metabolism through the intermediary of the plant. This transfer is the fundamental purpose of all food, and the banana is one of many foods that accomplish it. The nutrients in a banana beyond carbohydrates, including vitamins and minerals, come from the soil where the plant grew and from the air and water the plant used. These nutrients are assembled into the fruit through the plant's metabolic processes and become available to whoever eats the fruit. The potassium in a banana came from potassium in the soil, absorbed by the roots and transported to the developing fruit. The vitamin C was synthesized by the plant through biochemical pathways that combine simpler molecules. Each component of the banana's nutritional value has its own origin and pathway into the fruit. The systems that deliver bananas to consumers are maintained by ongoing work and investment. Plantations require continuous labor and management to remain productive. Packing facilities need equipment and infrastructure to process fruit. Ports require cranes and loading facilities to handle shipping containers. Ships must be built and maintained and operated by trained crews. Ripening facilities need specialized rooms and monitoring equipment. Trucks require fuel and maintenance to deliver fruit to stores. Stores need space and labor to display and sell the fruit. All of this infrastructure and activity exists to support the flow of bananas from where they grow to where they are eaten. The economic value created at each stage of the banana supply chain is distributed among different participants. Plantation owners or operators receive payment for the fruit they produce. Workers receive wages for their labor. Shipping companies are paid for transporting the fruit. Ripening center operators charge for their services. Retailers sell the fruit to consumers at a price that covers their costs and provides a profit. The total price paid by consumers is divided among all these participants, with each receiving a share of the value created by making bananas available. The proportions in which this value is distributed have been subjects of discussion and sometimes conflict within the banana industry. Concerns have been raised about whether plantation workers receive fair compensation for their labor, whether small independent growers receive fair prices for their fruit, and whether the benefits of the banana trade are distributed equitably among producing and consuming countries. These questions reflect broader issues about fairness and equity in global agricultural trade. Various certification programs have been developed to address some of these concerns. Fair trade certification aims to ensure that producers receive minimum prices and that certain labor and environmental standards are met. Organic certification requires that fruit be grown without synthetic pesticides or fertilizers. Rainforest Alliance and similar certifications focus on environmental sustainability and protection of ecosystems. These certifications provide some consumers with options to purchase bananas that meet certain criteria, though certified fruit typically costs more than conventional bananas. The vast majority of bananas sold globally are not certified under any of these programs but are produced and traded through conventional channels. The conventional banana trade has delivered low-cost fruit to consumers for decades, making bananas one of the most affordable fresh fruits available in many markets. This affordability has contributed to high consumption rates and has made bananas an important source of nutrition for many people, particularly in countries where they are grown and eaten locally. The environmental footprint of banana production and trade includes several components. Land use for plantations affects ecosystems and biodiversity, particularly if forests or other natural habitats are cleared to establish plantations. Water use for irrigation can stress water resources in some regions. Pesticide and fertilizer use can affect water quality and non-target organisms. Transportation of bananas over long distances requires energy and generates greenhouse gas emissions. Packaging materials create waste. Each of these impacts can be managed and reduced through appropriate practices, but they are inherent in the current system of large-scale commercial banana production. Local consumption of bananas in producing countries often involves fewer of these impacts because the fruit travels shorter distances and may be grown on a smaller scale with fewer inputs. In many tropical countries, bananas are grown in home gardens or small plots and consumed directly by the growers and their families. These locally consumed bananas are often of different varieties than the Cavendish variety grown for export, including plantain varieties that are typically cooked rather than eaten raw. Local banana production and consumption represents a simpler system with fewer intermediaries and less energy input. The existence of both local and global banana systems illustrates different approaches to food production and distribution. Local systems emphasize short supply chains, direct consumption, and integration with local foodways. Global systems emphasize specialized production in favorable locations, economies of scale, and distribution across long distances to reach large consumer markets. Both systems coexist, serving different purposes and different consumers, reflecting different values and priorities. The banana plant's ability to produce fruit without seeds is what makes it valuable for cultivation but also creates challenges. Without seeds, banana plants cannot be propagated by planting seeds as most crops are. Instead, they must be propagated vegetatively through suckers or through tissue culture in laboratories. This means that all the plants of a particular variety are genetically identical clones, derived from the same original source. This genetic uniformity makes the plants vulnerable to diseases that can spread rapidly through a genetically uniform population, as has happened historically with banana diseases. The history of the banana trade includes the rise and fall of the Gros Michel variety, which dominated exports in the early 20th century until it was devastated by Panama disease. The Cavendish variety that replaced Gros Michel is now threatened by a new strain of the same disease. This pattern illustrates the vulnerability created by genetic uniformity and the need for diversity in agricultural systems. Developing and deploying multiple varieties rather than relying on a single dominant variety could provide resilience, though it would require changes in production practices and consumer acceptance of different types of bananas. The banana continues its existence in whatever state it has reached. It's still green, it sits waiting to ripen, its internal processes proceeding slowly, converting starches to sugars, softening tissues, changing colors. If yellow and ripe, it offers itself as food, the culmination of all the processes that brought it to this point. If overripe or spoiling, it proceeds toward decomposition, the nutrients and energy in its tissues becoming available to bacteria and fungi that break it down, returning its components to simpler forms that will cycle through ecosystems. The story of any individual banana is unique in its details but follows patterns shared by all bananas of its variety grown under similar conditions. The particulars of which corm it grew from, which workers harvested it, which ship carried it, which ripening room it spent time in, which store shelf it sat on, and who eventually ate it or did not eat it make each banana's journey individual. Yet all these individual journeys follow the same general path from plantation to consumer, shaped by the systems that have been built to produce and distribute this fruit. The banana plant that produced the fruit continues its life cycle even after the fruit is harvested. The pseudostem dies back gradually, having completed its role. The corm underground persists, supporting the suckers that will become the next generation of plants. The energy stored in the corm supports the early growth of these suckers until they develop enough leaves to photosynthesize and support themselves. The continuity from one generation of plants to the next ensures that the plantation can continue producing without the need to replant from new stock. In the rhythm of the plantation, each plant progresses through its cycle: growth, flowering, fruiting, harvest, and death of the pseudostem, while new suckers grow to repeat the cycle. The timing of these stages varies among individual plants, creating the mosaic of different developmental stages visible in a producing plantation. This diversity of stages allows for continuous production, with some plants always at or approaching harvest while others are in earlier stages of development. The workers in the plantation develop deep familiarity with the plants and the cycles of production. Through daily observation and repeated performance of the same tasks, they come to understand what healthy plants look like, when bunches are ready to harvest, how to handle fruit to avoid damage, and countless other details of banana cultivation. This practical knowledge is essential to successful production and is passed from experienced workers to newer ones through demonstration and practice. The knowledge of how to grow, ship, ripen, and market bananas has accumulated over more than a century of commercial banana production. Early efforts to ship bananas to distant markets faced many challenges, with high rates of spoilage and uncertain quality. Over time, better practices were developed, refrigerated shipping was introduced, ripening techniques were refined, and logistics were improved. The system as it exists today is the result of this long process of learning and incremental improvement. The infrastructure that supports the banana trade represents substantial investment that has been built up over decades. Plantations have been established and expanded, packing facilities have been built, specialized ships have been constructed, ports have been equipped with necessary handling equipment, ripening centers have been established near major markets, and distribution networks have been developed. This infrastructure exists because of the demand for bananas and the economic value of meeting that demand. The demand for bananas in consuming countries has remained relatively steady over time, with people continuing to purchase and eat bananas at fairly consistent rates. This steady demand provides stability for the industry and justifies the investments needed to maintain production and distribution systems. Unlike some products where demand fluctuates substantially with fashion or changing preferences, bananas have maintained their place as a staple fruit that people buy regularly without much thought. The banana's success as a global commodity reflects several factors. Its nutritional value makes it useful as a food. Its convenience and ease of eating make it practical for busy modern lifestyles. Its mild flavor and soft texture appeal to many people, including children. Its ability to be harvested green and ripen later makes it suitable for long-distance shipping. And its productivity when grown in favorable climates makes it economically viable to produce at the scale needed to supply global markets. All these factors come together to explain the banana's prominent place in modern food systems. Yet the banana is only one of many fruits and foods that travel through global trade networks. Apples from temperate regions, oranges from citrus-growing areas, grapes from Mediterranean climates, and many other fruits follow their own paths from production to consumption. The banana is distinguished by its volume, with more bananas traded internationally than any other fruit, but it is part of a larger system of global food trade that moves vast quantities of food around the world every day. This global food system has made a greater variety of foods available to more people than at any previous time in human history. Someone living in a temperate climate can easily buy tropical fruits that would have been unavailable to previous generations in the same location. This increased availability has expanded dietary options and has made nutritious foods accessible across seasons and locations. At the same time, it has created dependencies on complex supply chains and raised questions about sustainability, resilience, and the concentration of control over food production and distribution. The banana rests wherever it has been placed, whether in a shipping container crossing an ocean, in a ripening room surrounded by ethylene gas, on a store display under bright lights, or in a kitchen fruit bowl. In each location, the processes continue. Respiration continues at a rate determined by temperature, with the fruit consuming oxygen and releasing carbon dioxide as it metabolizes its stored carbohydrates. Enzymes continue their work, breaking down compounds and building others, driving the changes that constitute ripening or, if ripening is complete, deterioration. The fate of each banana depends on factors beyond its control. Whether it is eaten at peak ripeness, used in cooking when overripe, or discarded when spoiled depends on human decisions and circumstances. Many bananas complete their journey by being eaten, fulfilling their purpose as food and providing nourishment. Others are wasted at various points in the supply chain, lost to spoilage, damage, or simply not being purchased before they deteriorate. Reducing this waste is a continuing challenge in the banana industry and food systems generally. Efforts to reduce food waste include better forecasting of demand so that stores order appropriate quantities, improved handling to minimize damage, technologies that extend shelf life, and consumer education about how to use fruit at different stages of ripeness. Despite these efforts, some waste is inherent in a system that delivers fresh, perishable produce to consumers over long distances and time periods. The challenge is to minimize waste while maintaining quality and availability. The packaging used for bananas serves protective and informative functions, but also creates waste. Cardboard boxes that protect fruit during shipping are often recycled, becoming material for new cardboard products. Plastic bags or liners used in some packaging systems may be disposed of as waste or recycled where facilities exist for plastic recycling. Reducing packaging waste while maintaining the protection that fruit needs is an ongoing consideration in the banana industry. At the consumer level, banana peels represent the most visible waste product from eating bananas. These peels are organic material that could be composted, returning their nutrients to soil, but in many cases they are simply thrown away and end up in landfills. In landfills, organic waste like banana peels decomposes anaerobically, producing methane, a potent greenhouse gas. Composting instead allows aerobic decomposition that does not produce methane and creates useful compost for gardening or agriculture. The circularity of natural systems contrasts with the linearity of many human systems. In nature, nutrients cycle through ecosystems, with death and decomposition returning materials to soil where they can be taken up by new plant growth. In modern food systems, nutrients and organic matter are often removed from where they were produced and transported far away, breaking the natural cycles. Returning organic waste to agricultural land through composting or other means can help restore some circularity to these systems. The banana plant in the plantation is part of a more circular local system. The dead leaves and old pseudostem from harvested plants decompose in place or are chopped and left as mulch, returning nutrients to the soil. The roots that decay after the plant dies also contribute organic matter to the soil. The suckers that grow from the same corm use nutrients stored there and nutrients taken up from the surrounding soil. This local cycling maintains some of the natural circularity even within an agricultural system oriented toward export. The sustainability of banana production depends on maintaining the resource base that supports it. Soil must remain fertile, water resources must be available and not depleted or degraded, and the climate must remain within the range that allows bananas to grow well. Each of these conditions faces pressures from how banana production is practiced and from broader environmental changes. Managing these pressures to ensure long-term sustainability requires attention and action from everyone involved in the banana industry. Climate change presents particular challenges for agriculture generally and for tropical crops like bananas specifically. Changes in temperature and rainfall patterns could affect where bananas can be grown successfully. Increased frequency of extreme weather events could damage plantations. Changes in the distribution and prevalence of pests and diseases could create new challenges for plant health. Adapting to these changes will require flexibility and innovation, potentially including development of new varieties, changes in growing practices, or shifts in where production is located. The banana serves as a lens through which to view larger questions about food systems, global trade, environmental sustainability, and social justice. How bananas are grown affects workers and ecosystems in producing countries. How they are traded affects economic relationships between regions. How they are consumed affects health and nutrition in consuming countries. How waste is handled affects environmental impacts. All these connections make the banana a useful subject for thinking about the complex systems that feed modern populations. Yet for most people, most of the time, a banana is simply a banana, a piece of fruit to eat without deep contemplation of its origins or implications. This ordinariness is not a failure but a success of the systems that have made bananas reliably available. The goal of food systems is to provide food simply and reliably, allowing people to meet their needs without difficulty. The banana achieves this goal, being there when wanted, easy to use, pleasant to eat, and affordable to buy. The quiet presence of the banana in daily life masks the activity required to maintain its availability. While one banana sits in a fruit bowl, others are being grown in plantations, harvested by workers, processed in packing facilities, loaded onto ships, transported across oceans, ripened in controlled rooms, delivered to stores, and displayed for sale. This continuous flow ensures that when one banana is eaten, others are available to replace it. The system operates constantly, maintaining the supply that consumers have come to expect. In the plantation, the sun rises on another day. Light falls on the broad green leaves of countless banana plants. Photosynthesis begins again as it does every day, capturing energy and building the organic molecules that will eventually be part of new fruit. Water moves up through roots and pseudostems, delivering moisture and dissolved nutrients to all parts of the plants. The slow growth continues, visible only over days and weeks as leaves expand, pseudostems thicken, and flower buds develop. The workers arrive for another day of work in the plantation. They move through the rows, performing the tasks that the day requires. Perhaps today some will harvest mature bunches, cutting them down with care and transporting them to the packing facility. Others might manage suckers, removing some and allowing others to develop. Some might inspect plants for signs of disease or pest problems. Others might perform maintenance on irrigation systems or carry out other necessary tasks. The work is routine but essential, the daily activity that keeps the plantation productive. The processing facility operates as it does every day, receiving harvested bunches and transforming them into packed boxes ready for shipment. Workers perform familiar tasks with practiced efficiency. Bunches are broken into hands are washed and treated, clusters are sorted and packed. The rhythm of the work is steady, moving fruit through each step of the process. At the end of the day, stacks of packed boxes are ready to move to refrigerated storage, awaiting their turn to be shipped. At ports around the world, ships arrive and depart on regular schedules. Containers are loaded and unloaded, moved from ships to shore or from shore to ships. The banana containers are just part of the larger flow of global trade, indistinguishable from outside, though their contents are specific and their requirements for refrigeration make them slightly different from containers carrying non-perishable goods. The movement is constant, ships always in transit, containers always being handled, the infrastructure of global trade operating continuously. On the ocean, ships plow through water on their predetermined routes. Inside refrigerated containers, bananas sit in darkness, held at controlled temperatures, unchanged from hour to hour as the ship makes its way across vast distances. The voyage is uneventful by design, a routine transit from one port to another, one more link in the chain connecting production to consumption. The ship's crew monitors systems, maintains the vessel, and guides it on its course, performing their roles in the larger system. At ripening facilities, rooms are filled with green bananas one day and emptied of yellow bananas a few days later, a continuous cycle of filling, ripening, and emptying. The operators adjust conditions based on experience and specific requirements, managing the transformation from green to yellow with practiced skill. The ripened fruit moves out to stores, while new shipments of green fruit arrive to begin the process again. The facility operates continuously, always with some rooms in the ripening process while others are being loaded or unloaded. Stores receive deliveries of ripened bananas regularly, adding fresh fruit to their displays as existing inventory is sold. The produce workers arrange the fruit, remove pieces that are overripe or damaged, and ensure that the display remains attractive and well-stocked. Throughout the day, customers select bananas and add them to their purchases. The display slowly depletes until the next delivery arrives to replenish it. This cycle repeats day after day, week after week, the rhythm of retail that keeps bananas available to shoppers. In homes, bananas sit in various states of ripeness. Some were just purchased and are still slightly green, days away from peak ripeness. Others are perfectly yellow, ready to eat. Still others are developing brown spots, entering the stage where they should be eaten soon or used in cooking. Each banana progresses through these stages according to its own timeline, influenced by temperature and other conditions in the home. Some will be eaten at each stage, while others might be forgotten and eventually discarded when they become too ripe. The consumption of bananas is continuous and distributed across millions of households. At any given moment, somewhere someone is eating a banana. The fruit is peeled, the flesh is consumed, the peel is discarded. This simple act happens countless times per day globally, the endpoint of all the processes that brought each banana from plantation to person. Each act of eating a banana is unremarkable in itself but represents the culmination of the entire system. The nutrients from eaten bananas enter human bodies and are metabolized. Carbohydrates are broken down into simple sugars that provide energy for cellular processes. Vitamins and minerals are absorbed and incorporated into various physiological functions. Fiber passes through the digestive system, contributing to digestive health. The banana that was a product of photosynthesis in a distant plantation becomes part of the metabolism of whoever ate it, the energy and materials transformed and put to new uses. The systems that produce and distribute bananas are not static but continue to evolve. New technologies may be adopted that improve efficiency or quality. Practices change in response to new knowledge or changing conditions. Consumer preferences shift over time, potentially affecting what varieties are grown or how fruit is marketed. Regulatory requirements may change, affecting production practices or trade relationships. The banana industry of the future will likely differ in various ways from the industry of today, though the basic pattern of growing fruit in tropical locations and distributing it globally may persist. Research continues into various aspects of banana production and use. Plant breeders and geneticists work on developing new varieties with improved characteristics. Agronomists study how to optimize growing conditions and practices. Plant pathologists investigate diseases and how to manage them. Food scientists explore ways to extend shelf life or develop new products from bananas. This ongoing research contributes to gradual improvements and helps address challenges as they arise. The economic importance of bananas in producing countries makes the health of the industry significant for many people. In some countries, banana exports represent a substantial portion of agricultural export income. Employment in banana production provides livelihoods for many families. Supporting industries such as packaging, transportation, and services also depend on the banana trade. The interconnections mean that changes in the banana industry can have wide-ranging effects in producing regions. For consuming countries, bananas represent a small but consistent part of fruit supply and dietary intake. The nutritional contribution of bananas is modest at a population level, but can be significant for individuals who eat them regularly. The affordability and convenience of bananas make them accessible to people across income levels, contributing to their role as a widely consumed fruit. Any significant disruption to banana availability would likely be noticed by consumers and could affect fruit markets. The resilience of the banana supply system has been tested by various challenges over the years. Hurricanes and tropical storms have damaged plantations in producing regions. Labor disputes have temporarily disrupted production or shipping. Diseases have affected plants and reduced yields. Economic crises have affected demand or changed trade patterns. Despite these challenges, the system has generally continued to function, with production shifting when necessary and supply chains adapting to maintain fruit availability. Looking to the future, the banana industry faces both challenges and opportunities. The threat from Panama disease requires urgent attention and may necessitate significant changes in varieties grown or production practices. Climate change will require adaptation to changing conditions. Consumer demand for sustainably produced food may drive changes in how bananas are grown and certified. Technological innovations may enable improvements in efficiency or quality. How these factors play out will shape the banana industry in the decades ahead. The banana plant continues its growth in the plantation, indifferent to these larger considerations. It responds to the immediate conditions it experiences: the sunlight falling on its leaves, the water available to its roots, the temperature of the air around it. The plant grows according to its biological nature, following patterns established over evolutionary time. Human cultivation has not changed this fundamental nature, but has selected for certain characteristics and provides conditions that favor growth and fruiting. The soil beneath the banana plant holds moisture and nutrients that the roots absorb. This soil is a complex mixture of mineral particles, organic matter, water, air, and living organisms. The interactions among these components create the environment that supports plant growth. The soil itself changes slowly over time, affected by plant uptake of nutrients, addition of organic matter, weathering of minerals, and activity of soil organisms. Managing soil health is essential for long-term productive capacity of the plantation. The climate in the banana-growing region continues to provide the warmth and moisture that bananas require. The sun shines, warming the land and driving evaporation that leads to cloud formation and rain. The rain falls, soaking into soil and running off into streams that flow toward the ocean. The cycle continues, powered by solar energy, distributing water across the landscape. The banana plantation is part of this landscape, depending on these natural cycles while also modifying them through irrigation and drainage management. The broader ecosystem in the banana-growing region includes many species beyond the banana plants themselves. Birds, insects, mammals, reptiles, and countless microorganisms live in and around the plantation. Some of these organisms interact with the banana plants, either beneficially or detrimentally from a human perspective. Managing these interactions is part of plantation management, whether through encouraging beneficial organisms or controlling those that damage plants or fruit. The interconnections between the banana and its environment are numerous and complex. The plant affects the environment by taking up nutrients and water, by creating shade, by providing habitat for some organisms. The environment affects the plant by providing necessary resources, by exposing it to weather conditions, by harboring organisms that may be pests or diseases or beneficial partners. These reciprocal influences shape both the plant and its surroundings in ongoing interactions. The passage of time in the plantation is marked by the cycles of plant growth and fruiting. Days accumulate into weeks, weeks into months, months into years. The same pieces of land produce banana plants year after year, with each generation of plants giving way to the next. Some plantations have been in continuous production for decades, the land dedicated to bananas for longer than many people have been alive. This continuity represents a commitment to banana production as a use of the land and a source of livelihood. The people who work in the plantation live their lives while performing their work. They have families, homes, aspirations, challenges, and joys like all people. The work in the banana plantation is their employment, how they earn income to support themselves and their families. For some, it may be one job among several they have held. For others, it may be work they have done for many years. The plantation is part of their daily reality, the place where they spend their working hours. The communities near banana plantations are shaped by the presence of the plantation. Local economies may depend heavily on the plantations and related activities. Services and businesses may cater to plantation workers and operations. The plantations may be major employers in the region, providing jobs that might not otherwise be available. The relationship between plantations and communities can be complex, involving both benefits from employment and income and concerns about environmental and social impacts. The flow of bananas from these communities to distant markets represents a connection between places that might otherwise have little relationship. The fruit grown by workers in one place is eaten by people in another place who may never think about where their bananas came from. This disconnection between production and consumption is characteristic of modern food systems, where long supply chains separate the people who grow food from those who eat it. Some efforts have been made to create more awareness of these connections. Fair trade and similar programs aim to make consumers more aware of conditions in producing regions and to ensure that producers benefit fairly from trade. Labels and marketing materials sometimes include information about origin or growing practices. These efforts try to bridge the gap between production and consumption, making the connections more visible and perhaps fostering greater appreciation for the work and resources involved in producing food. Yet for most consumers, most of the time, these connections remain invisible. The banana is simply there in the store, a product to purchase and consume without deep thought about its origins. This invisibility is both a strength and a limitation of modern food systems. It allows food to be available simply and conveniently, but it also obscures the realities of how food is produced and the impacts of our food choices. The banana plant grows, flowers, and fruits according to its nature. The fruit develops and is harvested, processed, shipped, ripened, and distributed. Someone purchases a banana and eats it. The peel is discarded and the fruit is consumed. This cycle has repeated countless times, for countless bananas, feeding countless people. It continues now and will likely continue into the future as long as the systems that support it persist. In the quiet moment of eating a banana, none of this history or complexity is usually present in consciousness. The experience is simple: the taste of the fruit, the texture, the satisfaction of eating. The banana is just food, fulfilling its purpose without fanfare. This simplicity is the goal, the desired outcome of all the work and all the systems involved. Food should be available when needed, easy to use, pleasant to consume. The banana achieves this goal remarkably well. It is there in stores most of the time. It is affordable for most people. It requires no preparation beyond peeling. It tastes good to many people, provides nutrition. These qualities make it successful as a food and explain its widespread consumption. The banana has found its place in modern diets through a combination of its inherent characteristics and the systems that have been built around it. The story of the banana could continue indefinitely, following more plants through their growth cycles, more fruit through harvest and shipping, more consumers through their purchases and consumption. Each individual instance adds to the vast accumulation of banana stories, unique in details but similar in pattern. The repetition is not monotonous but rather reflects the reliable functioning of systems that provide food consistently over time. In the plantation at this moment, banana plants stand in rows under the tropical sun. Their broad leaves capture light. Their roots draw water and nutrients from soil. Their pseudostems support developing fruit. Workers move among the plants, performing tasks that have been done many times before and will be done many times again. The rhythm continues, unhurried and steady, the ongoing work of producing food from soil, sun, and water. This is how bananas grow, how they are harvested, and how they reach stores, an everyday process that feeds people around the world.